Lesson 18, page S99. Equations involving a variable expression in the denominator. Nolan says that he checks the answer to a division problem by performing multiplication. For example, he says that 20 divided by 4 equals 5. That's correct because 5 times 4 is 20. And 3 divided by 1/2 equals 6. And that is correct because 6 times 1/2 is 3. We're going to use Nolan's reasoning and explain why there is no real number that is the answer to the division problem 5 divided by 0. All right, let's think about it. 5 divided by 0 has got to equal a number. That's what we're saying, that you could divide by. And if we use Nolan's reasoning to check our work, what we're going to find out is if we go 0 times n, what we're going to find out is 0 times n equals 5. But we know that 0 times anything is 0. If you have none of them, you've got 0. So 0 equals 5, which really, honestly, cannot possibly be true. This is a nice illustration of why we can't divide by 0. Quentin says that 0 divided by 0 is 17. What do you think? Well, if we take the same philosophy and we say 0 times 17, what we get is 0 equals 17 times 0, which does give us 0 times 0. So if we really wanted to argue about it, that would come out true. But the problem is that honestly, we could also say that 0 divided by 0, let me make that a little prettier of a 0, that's terrible, I can't do that to you. 0 divided by 0 could equal negative 13. And we could still prove it true. 0 equals negative 13 times 0, and 0 equals 0. And you know, as mathematicians, all of us, we do not like it when we get several answers to the same thing. 0 divided by 0 equals, oh, let's go crazy, 13,000. That means 0 equals 13,000 times 0. 0 is equal to 0. The problem is we're just not allowed to have 3 answers for the same question. We can't have 17, negative 13, and 13,000 all being the same answer. And I imagine you could probably see that we could put every single number we could think of in here and get the same thing. So his opinion is not too useful. Oh well, good try. Mavis says that the expression 5 over the quantity x plus 2 has meaningful value for whatever value one chooses to assign to x. Do you agree? So my question is, what if x plus 2 equals 0? We've already discovered the denominator can't be equal to 0, and if we think about that, then we discover that x is equal to negative 2. So I think we need to modify her statement and say something like, what we really need to say is the answer is fine as long as x does not equal negative 2. So we have to qualify what's going on here now. What we have to do is think about where we could run into trouble, and we have to think about variables in the denominator. denominator, not denominator. It could be the denominator. I don't think it is. It's denominator. All right. Must be checked for zeros. Remember, I keep telling you, zeros and ones are our big deal in this world. So Bernoulli says the equation 3x minus 6 divided by x minus 2 always has the value of 3 for whichever value one assigns to x. Do you agree? Well, let's examine what Bernoulli was probably thinking. He probably saw 3x minus 6 and thought, I could pull a 3 out of both parts of this one, and I would get 3 times x minus 2. Let me make that a minus 2 for you, hold on. And get 3 times x minus 2. And that would be over x minus 2, and that would be all good. And the truth is, yes, if we didn't have a variable in the denominator, we could make that move. The problem is we have a variable in the denominator. So his statement is true as long as we check for x minus 2 equaling 0. X would be 2, and remember, we can't have 0, so we want to negate that. So his answer would be good as long as x didn't equal 2. Bernoulli's answer is fine for all numbers except for 2.